6th. Wait a second. Okay, today is April 6th, 2011. You guys are on textbook page 164 and your blue notebook page 270. And we're going back a chapter. So we're going over to lesson 4.1. I wanted you guys to get down these definitions here. They're going to be pretty important for today's lesson. Okay? So first of all, delete this. First of all, we're going to talk about independent and dependent variables. So I'm going to say that maybe a teacher you knew once took stats on the amount of hours you study and somebody's grades. So what we're going to do is we're going to put hours studied on the x-axis, and we're going to put grades on the y. So let's say I took a survey of students and I plotted all the data. So I plotted this data here, and I discovered that depending on your hours of study, your grades would change. Okay? So what this is talking about is we're first going to be talking about an independent variable and a dependent variable. So before I even tell you what independent and dependent are, which of these two do you think would be considered an independent variable, and which one would be the dependent variable? Anthony? Grades are independent? Why would you say that? Okay, so, yeah, Miguel. Okay, so like Ricky said, our independent variable is going to be our hours studied. And dependent, our grades depend on the amount of hours studied. So our independent is the hours of study, and our dependent are our grades. So we've taken a look at this, and it looks like the more hours we study, the better our grades seem to get. Okay? Now before we move on, I'm going to go through a couple other cases of independent and dependent, just so we get an idea of what that means. So I'm going to make a little chart here. Oh, it's going to be at the top. So what we've written there is we've written a list of independent and dependent variables. When we have an independent variable, doesn't matter what it is, could be hours of study, play, time, work, that is always going to go on our x-axis when we go to write a coordinate down. Okay? Our dependent variable will always go on the y-axis when we go to write them down. So just like we did above, when we did your grades, and I'll rewrite that other part down, we had our grades and hours of study. Just get a D in there. Our hours of study. Our hours of study was on our x-axis, and it was our independent variable, and our grades depended on the amount of hours we studied. So we've covered independent and dependent variables. Next, we're going to talk about nonlinear and curve of best fit. So if you guys think back to grade 9, we're going to go back to this question in a second. I want you guys to think back to grade 9. Let's say we have a relationship like this. Would you say this relationship is linear?
Yeah.
Yes. Why? Because it's going in a straight line. So we'll call this a linear relationship. What about if we had something that looked like this? Jaden, what would it be? Nonlinear. So because it does not form a straight line, we have a nonlinear relationship. Now, when we go to put a line or a curve of best fit, what do you think would work better in our first graph? A line of best fit or a curve of best fit? Miguel? A line. So if we were to draw a line of best fit, it probably looks something like that. That would represent our data. Could I put a line of best fit in our nonlinear? No. All right, we're going to try a curve. So we're going to be using a curve of best fit. Hey, all right, I'm getting better. All right, so there's our curve of best fit that represents this data. So as long as it's not a straight line, what is it going to be called? Okay, I'm talking about the title though. Nonlinear, okay? And we will be using a curve to represent that data. Okay, so I want you guys now to work on text page 167, number 4. I'll give you about 10 minutes to work on this. working on stage here. Okay? Get this down. Question number 4. They've given us a table, and they're comparing the speed of a car to its fuel economy. So, very first thing I'm going to have to do is we need to figure out our independent and our dependent variable. So, independent, dependent. Anthony, what do we got? Speed is our independent. Okay. And fuel. Speed economy. So first of all, speed is measured in kilometers an hour, and the fuel economy is measured in liters per 100 kilometers. So what they're talking about is how many liters of gas the car uses when traveling 100 kilometers. So now that we figured out our independent or dependent variable, we need to make a graph, because question 4a says make a scatter plot of the data. So that's a good point. So first of all, when I go to make my graph, we know our independent variable is going to go on which axis? X-axis. And our dependent variable is going to go on, good, the y-axis. And importantly, when we go to make our graph, we need to make sure it's scaled to what we're doing. So, first of all, what does the speed range from? What's the lowest number of speed? Liam? 10, and what's the highest number we get to? 150. So we're going to need a pretty large scale when we go to make this graph. Okay, so after we've made our graph here, and we know that our independent and dependent variables, we have speed and fuel economy, we're going to label them. So we have our speed is going to be on our x-axis, and fuel economy is going to be on our y-axis. We're going to need to plot the data because they're asking us to make a scatter graph. So question 4a asks us to create a scatter plot. We put all of our points down on the graph. At first glance, what does it look like we have here? First of all, what type of relationship is this going to be? Here we go. Nonlinear. So we have a nonlinear relationship. What am I going to have to use? Am I using a line of best fit or a curve of best fit to represent the data? Paulo? Yeah, we're going to be using a curve of best fit. Yeah. So we're going to go put our curve in. I'm going to try to be as best as I can here. Hey, I'm getting better with this. There we go. So we have our curve of best fit. Question D says, to use your model to predict the fuel economy at 200 kilometers an hour. So we have to follow this line we've made. We've got to go up to about 200. So if I was to continue this, I'm going up, 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 up. What are we reaching around 200 kilometers an hour? 40. So we're looking at around 40 liters per 100 kilometers. Our car is far less efficient now, the faster we're going. And finally, this car does not get very good fuel economy. So what would a graph of a car with good fuel economy look like? What would happen to this curve of best fit? Anthony? Come and draw it for me. So an example of one car that has a better fuel economy, we'll say it's the exact same type of curve, but just lower. And that would be an example. All right, so your homework tonight, guys, page 276 has the homework from the textbook, 1, 2, 3, 4, and 6. You've already done 1, 2, 3, 4, and 6. So your text page, 166, numbers 1, 2, 3. You've already done 4. I did it on the board for you, and 6. Okay, guys? That's your work. You have